For weeks, this MiG-29 has been hunting Ukrainian drones over the Black Sea, flying low-altitude patrols out of Kacha airfield in Crimea. Its pilot has logged dozens of intercept sorties, chasing down slow-moving reconnaissance UAVs and calling in coordinates for air defense batteries. Tonight, the aircraft sits in a concrete revetment, engines cold, pilot asleep in nearby quarters. 400 kilometers away, a weapon is already in the air to make sure the plane never flies again, and the Russians don't know it's coming. At 0600 hours local time, a pneumatic catapult hurled a UJ-26 Beaver drone off its launch rail west of Kherson. The rear-mounted propeller caught air immediately, and the drone climbed to 60 meters, leveled off, and throttled into cruise mode. Quiet enough that a soldier standing 500 meters away would hear nothing but wind. 3 Ukrainian special operations soldiers had less than 2 minutes to disappear. They folded the launch rail in 12 seconds, threw thermal blankets into the truck bed, and rolled out of the field on a dirt track paralleling an irrigation channel. The Beaver was already 2 kilometers downrange, climbing toward cruise altitude. Kacha airfield, 398 kilometers southeast. But the Russians were already hunting. 14 miles east, a Pol 21 electronic warfare tower registered an anomaly the moment the Beaver powered on. The system blankets the Dnipro corridor with passive receivers tuned to detect satellite navigation signals. The Beaver's encrypted GPS handshake had transmitted a frequency-hopping burst in the L-band, only 4 milliseconds long, but enough to spike the noise floor on Russian sensors. A duty officer with Rubicon, Russia's dedicated drone crew hunting unit, flagged the anomaly. Possible long-range UAV launch in progress. General coordinates, the Kherson sector. Within minutes, an Orlan 30 surveillance drone launched 6 kilometers east of the suspected launch point. Its thermal camera began scanning anywhere they could have launched from, searching for the heat signature of a vehicle that couldn't have gone far. If you look at the Beaver now climbing through 400 meters, you'll understand why Rubicon prioritizes neutralizing operators over shooting down drones. The airframe is 2.5 meters of fiberglass composite stretched over a canard configuration, small forward wings for pitch control, a swept main wing for lift, and a rear-mounted propeller pushing 160 kilometers per hour. The composite construction produces a radar cross-section of just 0.01 to 0.03 square meters, smaller than most birds. At night, flying low over terrain clutter, the Beaver is essentially invisible to Russian air defense. But the operators are not invisible. Rubicon knows that trained drone crews take months to develop, months of learning RF discipline, autonomous navigation management, and terminal guidance under pressure. Eliminate the operators, and Ukraine loses something far more valuable than a single drone. The MiG-29 at Kacha could be replaced in weeks. The men who launched this mission could not. The Orlan's FLIR camera you see trying to hunt the Ukraines operates in the 3 to 5 micron band, sensitive enough to detect a vehicle engine that shut down 20 minutes ago. Residual heat decays at roughly 2 degrees Celsius per minute, which meant the Ukrainian truck would remain visible for another 15 to 20 minutes. The Ukrainians knew this. They pulled into a collapsed barn, cut off the engine, and draped thermal blankets over the hood. For the next 8 minutes, they would sit in absolute silence while the Orlan searched overhead. On the Orlan's thermal display, a ghost image flickered where the truck had been idling. The exhaust plume from launch had dissipated, but the camera caught the fading heat bloom of compressed grass where the vehicle's tires had sat. The operator vectored toward the anomaly. That's when Rubicon dispatched 2 FPV hunter teams. If you look at the FPV drones these teams carry, you'll understand why they're so effective. Each aircraft weighs less than a kilogram, flies at 120 kilometers per hour, and carries a fragmentation charge capable of destroying a vehicle's engine block. But the real advantage is numbers. A single hunter team carries 6 to 8 FPVs, enough to saturate a search sector and force the target into a mistake. The drones fly nap of Earth, 10 to 15 meters above the ground, where their small thermal signatures blend into terrain clutter and their acoustic footprint stays below ambient noise until they're within 200 meters. The FPV teams fanned out along the 2 most likely exfiltration routes, a paved road north toward Kherson and a dirt track, west toward abandoned farms. Russian doctrine assumes drone operators will choose speed over concealment after launch. Staying near the launch site means eating a drone for sure. The Ukrainians took neither route. They sat in the barn, breathing shallowly, watching through a crack in the wall as an FPV passed 400 meters to the east. The Beaver was now 50 kilometers downrange, climbing toward its cruise altitude of 800 meters. It would fly the next 350 kilometers in complete silence. No uplink, no telemetry, no emissions of any kind. The operators couldn't see where it was going. They couldn't correct its course. They had to trust the navigation system to deliver the drone to Crimean airspace, while they focused on staying alive. At 06:16 hours, the Orlan passed directly over the barn. Its thermal camera registered the structure as ambient temperature. No vehicle, no personnel, no target. Rubicon logged the search as inconclusive and escalated to the next phase. The Beaver crossed the Dnipro River at 06:35, flying southeast toward Crimea on a heading that would take over 200 kilometers of open steppe. No terrain masking, no cloud cover, just composite airframe the size of a dining table cruising through radar coverage that extended 300 kilometers in every direction. And yet Russian air defense saw almost nothing. If you look at how the radar interacts with the Beaver's airframe, you'll understand why. Radar returns depend on the relationship between wavelength, target size, and aspect angle. The Beaver's composite skin absorbs and scatters radar energy rather than reflecting it cleanly back to the receiver. At grazing angles, when the radar beam hits the aircraft from below at a shallow angle, the return drops to nearly zero. Russian search radars operating in the S-band can theoretically detect a 0.03 square meter target at 40 to 50 kilometers, but only if the geometry is perfect. The Beaver's flight path was calculated to avoid these geometries. The drone flew towards the Russian MiG on pure inertial navigation. Its GPS receiver still active, but not transmitting position updates back to the operators. The inertial navigation system tracks acceleration and rotation through inertial gyroscopes and accelerometers, dead reckoning the aircraft's position based on where it started and how it's moved since. The system drifts over time, roughly 30 to 40 meters per minute without GPS correction. But over a 400-kilometer flight, that error accumulates to less than a kilometer, close enough for the terminal phase, where the operator can take control back over. Back at the Rubicon Operations Center, analysts were running Reverse Vector Reconstruction, or RVR, using some high school math lessons you probably thought you'd never use again. When a Russian radar, or multiple radars, detects even a fleeting contact, the system logs the bearing, altitude, and time. Plotting those detections on a map creates a track. Extending that track backward projects a cone of probability toward the likely launch origin, the more narrow the cone. The Beaver had been painted twice, once by a Crimean early warning radar at 0641 and again by a mobile S-300 acquisition radar at 0649. Neither detection lasted more than 2 seconds. Neither produced a fire control solution. But together, they gave Rubicon a backward bearing that pointed directly at the Kherson orchard sector. Rubicon overlaid the RVR cone with terrain analysis, dirt road density, vegetation cover, historical strike patterns, and known Ukrainian staging areas. The cone narrowed to a 20-kilometer corridor, exactly where the operators had launched. A second wave of Orlan 30s launched toward the exfiltration routes. FPV teams repositioned to cover bridges and canal crossings. Somewhere in that corridor, 3 Ukrainians were hiding in a collapsed barn, waiting for the hunt to move on. The net was tightening, and the operators couldn't warn the drone even if they wanted to, because any transmission would give Rubicon exactly what it needed. At 0700 hours, the Beaver's flight computer registered a GPS anomaly. The signal strength dropped from 5 satellites to 3, then flickered to 2. The navigation solution degraded from sub-meter accuracy to a 50-meter error circle that jumped erratically across the map. Russian electronic warfare had found the corridor. The Zhitel system you see here operates from truck-mounted platforms positioned along likely UAV approach routes. Its directional antennas broadcast GPS jamming in the L1 and L2 bands, creating noise cones that extend 30 to 50 kilometers. The jamming doesn't destroy the drone. It degrades the navigation accuracy and, more importantly, creates pressure on the operators to break radio silence. This is because of the 4 directional emitters mounted on a hydraulic mast that extends 12 meters above the vehicle. Each emitter broadcasts a 500-watt jamming signal in a 60-degree cone, and the system can rotate to cover a full 360-degree arc or concentrate all 4 emitters on a single bearing for maximum power. The jamming works by flooding the GPS frequencies with noise that overwhelms the weak satellite signals. GPS satellites transmit at just 20 watts from 20,000 kilometers away, so even modest interference can drown them out. The Zhitel's effective range depends on terrain and atmospheric conditions, but under optimal circumstances, it can degrade navigation accuracy for any drone within 50 kilometers of the antenna. Tonight, 3 Zhitel vehicles were positioned along the Crimean approach corridor, their coverage zones overlapping to create a continuous jamming blanket that the Beaver couldn't avoid. The Beaver's flight computer switched to INS-only mode. Drift began accumulating immediately, 35 meters per minute, compounding with every passing second. Over the next hour, the drone would wander nearly a kilometer off its programmed course. That error was still recoverable during terminal guidance, but only if the operators could re-establish contact and correct the approach. Back at the barn, the team monitored their relay station status panel. The Beaver was beyond direct radio range as it continued to close in on the Russian MiG, and the mid-course phase required complete emission silence. They had no way to correct the navigation drift or even know if the drone was still flying. All they could do was wait for the terminal phase and hope the drone arrived close enough to the target for optical guidance to work. But while they were worried about this, Russian FPV hunter teams were still searching. At 07:14 hours, an FPV passed within 400 meters of the barn. The operator watched its thermal camera feed sweep across the structure, pause for 2 seconds, then continue east. The barn's collapsed roof had created an irregular thermal profile that masked the truck hidden inside. The blankets had cooled to ambient temperature. The team had stopped breathing. The FPV moved on. Rubicon was not trying to shoot down the Beaver. Russian commanders understood that long-range composite drones routinely defeat short-range air defense systems. The radar cross-section is too small, the flight altitude too variable, the approach vectors too unpredictable. Shooting down one drone meant nothing if 10 more launched tomorrow. But trained operators were irreplaceable. The months of discipline required to execute a mission like this, the silent launches, the perfect exfiltration, the calm under pressure, could not be mass-produced. Rubicon's entire doctrine centered on one calculation: eliminate the human, and the drone program goes down with them. At 07:21, the team restarted the truck. The engine had cooled enough to reduce its thermal signature below detection threshold. They rolled out of the barn and turned south, away from the search pattern, toward a safe house 14 kilometers away. The Beaver was now 180 kilometers from Kacha Airfield. Terminal phase would begin in less than 40 minutes. At 07:59, the Beaver crossed into Crimean airspace, now roughly 100 kilometers from the MiG. Its onboard computer activated the optical guidance camera and began transmitting a narrow beam uplink toward the relay station hidden in Ukraine-controlled territory. For the first time in 2 hours, the operators could see what the drone saw. The video feed was grainy, compressed for bandwidth, degraded by atmospheric interference, jittering with the 120 millisecond latency that made fine corrections feel sluggish. But the Kacha airfield was there, a gray smear of runways and revetments resolving slowly as the Beaver descended toward attack altitude. The operator identified the target, a MiG-29 parked in a concrete shelter with its nose visible beyond the blast walls. He began steering corrections. Rubicon detected the uplink instantly. That's because the Beaver's terminal guidance system uses a directional antenna to minimize detection, but even a tightly focused beam produces side lobe leakage, stray RF energy that spills beyond the main transmission path. Russian SIGINT arrays along the Korean coast are calibrated to detect exactly this signature. Within 4 seconds, Rubicon had a bearing. Within 8 seconds, they had triangulated the relay station's approximate position. If you look at how Russian detection finding works, you'll understand why even a narrow beam uplink can't hide. Rubicon operates a network of passive receivers along the Crimean coastline, each station equipped with circular antenna arrays that measure the phase difference of incoming signals across multiple elements. When the Beaver's uplink activated, 3 stations detected the side lobe leakage simultaneously. Each station generated a bearing line toward the transmission source. Where those 3 lines intersected on the map, Rubicon had a grid coordinate, accurate to within 200 meters. The entire process, from first detection to firing solution, took 11 seconds. By the time the Ukrainian operator completed his first steering correction, Rubicon already knew where to shoot. The bearing pointed back toward Kherson, directly along the corridor where the FPV teams had been searching for the past 2 hours. Rubicon fired everything: FPV drones along the triangulated bearing, a Lancet loitering munition toward the most likely vehicle route, artillery coordinates to the nearest battery for fire mission approval. The operators had no idea any of this was happening. They were focused entirely on the camera feed, watching the MiG-29 grow larger in the frame, making micro corrections to align the Beaver's nose with the aircraft's cockpit. Latency made every input feel delayed. The drone responded a heartbeat after the command, forcing the operator to anticipate rather than react. At 08:05, an artillery shell landed 2 kilometers behind the safe house. The team froze. The relay station's signal strength held steady. The shell had missed the antenna, but Rubicon had their grid coordinates now, and more shells were coming. The operator forced himself to ignore the explosions and focus on the screen. The Beaver was 2 kilometers from target, 90 seconds to impact. A second shell landed 1,000 meters east. The team's security element reported FPV drones inbound from the north. 3 contacts, closing fast. The operator checked the camera feed. The INS drift accumulated during the Zhitel jamming had pushed the Beaver 340 meters left of the aim point. At the current heading, the drone would miss the revetment entirely and slam into an empty taxiway. He needed one correction, a 3-degree heading adjustment that would take less than 2 seconds to transmit. He sent it. The operator kept steering. The MiG-29 filled the camera frame. 60 seconds now. As the Beaver drone began its terminal dive, the 3 Russian FPV drones screamed toward the transmission source at 140 kilometers per hour. On Rubicon's tactical display, the bearing lines converged on a bombed-out apartment complex 14 kilometers south of the original search area, exactly where the triangulation said the Ukrainians were broadcasting. The lead FPV dove at a 60-degree angle, its camera locked onto a structure with a makeshift antenna array visible on the roof. The pilot didn't hesitate. At this stage of the hunt, speed mattered more than confirmation. The first drone struck the antenna housing dead center. The fragmentation charge detonated, shredding the transmitter array and collapsing the roof section onto the equipment below. The second FPV hit 2 seconds later, punching through the already damaged structure and detonating inside. The third impacted the north wall, ensuring nothing inside survived. Rubicon's tactical officer watched the feed go white with each explosion. 3 direct hits. The transmission source was destroyed. Artillery continued falling around the grid coordinate for another 60 seconds, churning the rubble into dust. When the barrage lifted, nothing remained of the structure but scattered concrete and twisted metal. Thermal imaging showed no movement or heat signatures. Rubicon logged the mission as a successful mission. The Ukrainian drone team had been neutralized. Whatever the Beaver did now, it was flying without guidance. A dumb missile drifting on corrupted navigation. No longer a threat. But Rubicon had made one assumption that cost them everything. They assumed the operators were there. The 3-man team was a kilometer south, inside a basement with no antenna, no transmission equipment, and no RF signature. The relay had been remote operated from the moment they set it up, a deliberate sacrifice, positioned in a separate structure precisely because Rubicon would target any transmission source. The operators had never been within 500 meters of the equipment the FPVs just destroyed, and the final heading correction had already uploaded. The Beaver's flight computer held the new course locked in memory, no longer requiring external input. The 3-degree adjustment had pushed the MiG-29 back to center frame before the relay went dark. The drone didn't need the operators anymore. At 08:06 hours and 34 seconds, the Beaver struck the MiG-29. The 20-kilogram KC-6 shaped charge detonated on impact. The pressure wave ruptured the fighter's aluminum skin from nose to tail. The cockpit disintegrated. Aviation fuel sprayed across the concrete revetment and ignited a half-second later, sending a fireball 40 meters into the Crimean sky. Secondary explosions rippled through the airframe as ammunition cooked off and hydraulic lines ruptured. When the flames subsided, nothing remained but a blackened skeleton of titanium spars and melted wiring. Bye for now.